Hello friends, welcome to the course Foundations of R Software and welcome to the last lecture of the course. So now you can see we have learned many aspects of the R software, basic commands, basic function, how to create graphic, how to write functions, etc. Now in this lecture I am not going to entertain any new topic, but my objective is that I just want to show you some salient features of the R software through the programs. And my objective is this: I would like to explain you how you can write a program in the R software, and for that I will try to take a couple of examples, and through those examples I will try to show you the different features of this R programming. Well, I have here one question that some of the candidates may not be knowing anything about the programming and some candidates may be knowing very well about the programming. So what I am going to do that in the first couple of minutes I am going to give you a very brief introduction to the programming, that what do we expect and why do we do this programming, and after that I will try to take a couple of examples to explain you the different types of applications and features of the R programming. So let us begin our lecture and try to understand first the very basic fundamentals of this programming and to know why do we need programming. So let us begin our lecture. So you see, first question comes here: what's a program and what are the different steps to write a program? So a program is simply a set of instructions or commands which are written in a sequence of operation, that whatever you want to do first, they are written first, and then whatever you want to do in the second step, they are written at the second step, right? So whatsoever come first and whatsoever come after that, all the instructions are given in a sequence, right? And the objective of a program is to obtain an outcome which is predefined and which is based on some input variables and some given mathematical function. And the only thing is this, that we can do such calculations and manipulations manually also, but we try to take the help of computer, and the computer is instructed to perform this defined task. The only reason is that because computer is an obedient worker and it can get our things done fast, and the only issue is this: the computer does not understand our language like as Hindi or English, but computer has its own language. And our problem is this: we don't understand the computer's language and computer does not understand our language too. So now what is the solution? The solution comes through this software. The software helps us and works like an interpreter between us and the computer. Whatever we try to give or whatever we type in program in English language, they are translated to the language of the software so that the computer can understand it. Computer does the work and then it is reverted back in the same language what we know. And what we try to do, we try to say something in the software language and software informs to the computer. Computer does the task and informs back to the software, and then software retranslate the outcome into our language and inform us through the outcome, right? And we already have discussed that the programs in the R software, they are written in the form of a function, and in order to write down function or the program, we have to first define the objective, and we should know what we really want to obtain as an outcome of a program, and then we try to translate it to the language of R, that how to communicate with the R using the commands and functions. And in order to do it, first we try to identify the input and output variables. We try to identify the nature of input and output variables, like as whether it is numeric, string, factors, matrices, etc. Now you know all of them, right? And now this input as well as output variables, they can be a single variable, they can be a vector valued matrix, or even a function itself, right? And whatever are the input variables of the program, they are the component of this function, and these components are reported inside the argument that is here within the parenthesis of the command function. One thing you have to keep in mind, that whatever is the outcome of one function, that can also be an input for another function, right? And that is the biggest advantage of this R software, that you can call within a function and that will try to work as an input also, right? And the output of an outcome can be formatted as per the need and requirement, that can be printed, soft copy, hard copy, they can all be arranged, right? So some very basic and fundamental tips for the programmer who are going to use the big data. Usually it has been observed that that loops usually slower the speed of programs. They consume more space in memory. So people try to prefer to work with the vectors and matrices, which makes the speed of the programs quite fast. At this moment we are trying to handle very small programs in which the speed doesn't make much difference, but when you are trying to write down the big programs dealing with big data sets, then you will see that sometimes it takes long time to execute a program. And to my experience, when we are trying to conduct the simulation, this time can be from couple of seconds to this couple of days, right? And then always try to use the hash symbol to write the comment inside the program so that you can understand the syntax at some future point, and then try to use the names of the variables which are easy to understand. For example, if you have two variables, height and weight, so it is better to use height for height and weight for weight. If you try to indicate the height by the variable weight or vice versa, then it will be very confusing. And don't forget to initialize the variables and try to remove it from your memory before you begin. Otherwise, some earlier variables or earlier values will take over and we will never come to know, and the outcome will be very different. Okay, so now I try to take here a couple of examples, and one thing I can accept before beginning the example, that my objective here is not really to teach you programming or to explain you that how are you going to write the program. My objective is very simple. I want to show you that whenever you are trying to write a program, what are the different aspects which you have to keep in mind and how you have to proceed. For example, in this example, I just want to write a program of the summation xi square upon summation y square and summation xi upon yi whole square. Well, I will show you that this command can be written now, you know, in a very simple words, that if you try to have the two data vectors consisting of the values of x and y as x and y, then this can be written here as a simply here is sum x hat 2 divided by sum y hat, whereas this can be written here as a sum x upon y whole square. But my objective is not to compute this value, but I want to show you the steps, and well, those steps are going to be couple of steps, and but finally I will show you that the length of the program is very less, but then I'm trying to explain in a more detailed way so that it will carry over to the couple of slides, but it does not mean that the program is long or it is complicated, right? So suppose I want to compute here these two quantities, so I try to denote the summation xi square upon summation y square as g and summation xi upon yi whole square as a h. So obviously what we need here, that we need to store the values of xi in a data vector x and the values of yi in a data vector y, so we try to denote them here as x and y, and now you can see here this is here n. So in this case I have taken the summation which is going to the equal number of observation, but if there are say different number of observation, then you can use here n1 and n2 also in place of n without any problem, and I try to denote this function as a g and this function here as a h. Right, now if I try to explain you that how I am going to do here, that I wish to show you the application of the loop, so that is why I am just trying to write in a more detailed way so that you can understand. At least those candidates who don't have very strong programming background, they will also be able to understand, and those who have very good programming language, for them it is very easy example. So as a first rule of the programming, that try to remove all the data from your memory so that you know what you are going to give, that is going to be used later on. And definitely when you want to execute the program, you need some data input values, so I try to define here x and y here as a like this. X takes say 3 values, x takes 10, 20, 30 and y takes 1, 2, 3. Yeah, you can take anything and this number can be anything. Now I want to write a program to find out this g and h, right? So I just try to give it here a name, say here example 1. So this is the name of the program, and after that I will try to write down here the command function function, and within parenthesis you have to give the input vector. So now you have here x and y, and yeah, the value of n I am going to compute it from the number of observations in x and y, right? So now I begin here the starting of the function. So for that I have to write down here a curly bracket, and then after that I have to give here all the input command for the computation. Now the first input value comes here, which we have not defined, is the value of here n. So for that, instead of giving it from outside, I try to give it from inside using the command length length of x. Actually this is always a better idea, that when you are trying to compute something, try to write command in which the things are calculated automatically, otherwise there can always be a chance of mistake. And now since I want to use here the the loop, so I try to see here if I am trying to find the value of here summation xi square. So what I have to do, first I have to find out the value of x1 and then x1 is square, and then I have to find out the value of x2, and then I have to add it in the say x1 is square, like as x1 square plus x2 square, and then I have to get here the value of x3, and then I have to add this value x3 square in the earlier obtained sum. So for that, in order to begin the loop, I have to take here say some initial value. So I try to define here one initial value for summation xi square, one initial value for corresponding to summation y square, and one initial value for summation xi upon yi whole square, which I am going to call it here as a summation of chi square. So that is why I have defined here x1, y1 and z1, which all take value 0. Now I begin here the loop and I choose here the for loop. So for loop you have to write for and then within parenthesis I in 1:n. Now I need to define here this x1, y1, z1 so that the individual values of say xi square, yi square and xi upon yi whole square, they can be stored. So I try to define it element wise, so you know that when you are trying to write down here x1 and inside the square bracket you are trying to write down here I, that means the ith value in the value will be stored here. So I write here x1 I is equal to x inside square bracket I and then whole square. So whatever is the ith value of the data vector x, that will be squared and that is going to be stored in the variable x1 at ith location. Similarly, the value of yi square will be computed by the command y square bracket I whole square, and that is going to be stored in the variable y1 at the ith position. And similarly, I try to define here one more variable here zi. So zi is something like here xi upon yi. So this becomes here x square bracket I divided by y square bracket I, and it is square. So now this value is going to be stored in a new variable here z1 at the ith position. Right. So now this completes my loop and I give here this bracket. So this loop is, you can see here within these two brackets, these two curly brackets, right? And now I have to obtain the sum of all the values in the x1, y1, z1. So I try to define here a variable here sum underscore square underscore x, and then using the function sum I can find out the summation xi square as has say here sum of x1, and similarly I can find out summation yi square and summation xi upon yi whole square by using here the command sum of y1 and storing it to sum underscore square underscore y and sum of z1 and storing it to a new variable sum underscore square underscore z. Right. So now I have obtained here this summation xi square, summation y square and summation xi upon yi whole square. Now I need to compute my here g and h. So g is simply your here summation xi square upon summation y square. So I try to define here this sum of square of x divided by sum of squares due to y from these two values, and then h, that is already the sum underscore z. This has been obtained here also. Now after this I want to take the output in the format that the value of g and h, which is a string, is like this r, the value of here g and then string h and then the value of here h, and then here next line. So now you know all these commands. So I use here the command here cat function and I want here a formatted outcome. So now after this I will get here the outcome in the way I want, and if you try to see this function in a single slide, you can see that it is not a very difficult program. I have just given here the input and initial values, and here it is here the loop function, and then I have here defined the sum of squares, and then I am defining here g and h, and here is the outcome. That's all, right? And if you try to see it in the R console also, it will look like this, and means when you try to type it inside the R console, there will be here plus sign. Now you know what is the meaning of this plus sign, right? And now after this, since you have taken the value of x to be here 10, 20, 30, the value of y to be here 1, 2, 3, then you try to write down here example 1 and within parenthesis xy to execute it, the outcome will look like this. The value of g and h are 100 and 300 respectively, and now you know how this outcome is coming, right? Similarly, if you try to take here one more example in which you are trying to take different values of x and y and then you try to execute it, now once again the similar output will come in which the new values of g and h are going to be reported. The value of g and h are here like this and this respectively. So you can see here another advantage is that just by using the values of say x and y, you can very easily execute the program as many as times you want, and depending on the value of here g and h. And this is here the screenshot. So before I try to move forward, let me try to show you this example on the R console. So I try to just copy this command on the R console so that you can see here, this is here like this, right? So if you try to see here, your program here is like this, example 1, you can see here like this, right? So now if you try to define here x is equal to, suppose here is 10, 12, 14, and then y here as say here c, it can be anything 34, 76, 12 and so on. And then if you try to write down here example 1 and then x and here y, see here the outcome will look like here this, right? The values of h, g and h are like this. And in case if you try to replace or you try to change the values of here x and y here like this, suppose if I want to add here some more values here like this, and then similarly if I try to take here some values of here x like this, I try to now make it here 5 values in place of 3, and if I try to use an example 1 xy, you will get here this new values, and you can see here this is the value of g and h are like this, right? So you can see here it is not a very difficult job to write such program and to execute them, right? So now as I told you that if you really want to ask me how to write this program efficiently, then I can write down the values of g and h in a single line like this. This is quantity is your here sum of x square, and summation y square is summation like is a sum of y hat 2, and then this here is here like the sum x upon y and say hat 2. So you can see here just by using the commands of the R software which have been defined in a very mathematically friendly way, you can write such functions in a single line, right? So that is the advantage, that is what I was telling you right from the beginning, that this R programming and built-in functions helps you a lot in writing the program compactly and efficiently. Right, so now let me try to take here one more example, and where I try to show you that I want to compute this function. Right, so if you look at this function very carefully, you can see here this is here a function x plus log of y divided by y, which is used here at say here 3 places. So I try to rewrite this function as here gxy, and then this fxy can be rewritten as say gxy whole square from here, and then 5 plus gxy whole cube, and then exponential of gxy raised to the power of 2 by 3. Right, now I want to show you something here. So you can see here in this case there are 2 input variables, say x and y, and the output is that okay, you want to compute the say here function and you want to know the value of your fxy. So but if you try to see here that this fxy, this is depending on the value of here gxy. So what we can do here that we can compute here gxy and use it as an input variable inside the fxy. So how to get it done? And the advantage that the more complicated programming can be broken into different components, simple components, and different people can write the programs, and then this program can be joined together without any difficulty. So as usual, I will try to remove all the data, and then I will try to define here the input variable. That is the first step. Now in the second step, I simply try to define here gxy and fxy. So you see now this gxy here is like this. So writing down this function is very simple. Define here g and then function, and then within parenthesis xy, and it is simply your here x plus log y divided by y. So that you already have learned that how to define this natural log, and then this will complete your function. And similarly, if you try to now define here this function here, so you already have defined here this here g here, right? So now you would try to bring this value of g here directly here. So it is like here you can see gxy whole square, which is here, then this 5 plus gxy cube, which is here, and then after this exponential of gxy raised to the power of 2 by 3, which is here, right? So you can see here now I have written this program. Now in case if you try to see briefly in a single slide that how this program can be written, this is just your here gxy and this here fxy. Yeah. Now if you try to see one very peculiar characteristic of this R programming, here you are trying to use here gxy as an input. So that means when you try to execute this function here f, it is going to look for the value of gxy, and the value of gxy is being computed externally outside this function. So the function g should also be available at the same place where you are trying to write down the f function, right? So this is how I try to write down, and this is my here the screenshot of this program. Now if you try to see what I am going to do, that is very interesting, and that is what you have to observe. I simply define here x and here y, and I execute here fxy, and we are getting here this value. Now think and tell me, where is your gxy? You have not computed the value of gxy, but you are simply computing here the value of fxy. But what is happening that when you are trying to compute the value of fxy, this program goes outside and then it tries to compute the value of gxy. Just like here, I can explain you on this screenshot. When you are trying to compute here fxy, then control comes over here and it tries that, okay, there is a function here gxy. So this function comes out of this program and in the same directory it tries to search where is this gxy. So it is going to take the same input value x and y to this function gx here, and it will try to compute this function and then it will try to bring it here. So you can see here the function is automatically jumping out of the function. It is going to the other function, it is trying to compute the values and it is trying to bring back the numerical values as an input to the next function, right? So this is what is happening here. And similarly, if you try to change here the value of here x and y, you will get here new values. And you can see here there is no need to calculate the value of gxy. So now if you try to extend this concept to bigger example, that there is a very complicated function and as a programmer you try to divide the programming in say here different components and you try to give it to the different people in your organization, and all of them, they are trying to just write the program for a small section of the program, and then you are trying to just use all of their program and try to combine or try to call them in a single program, right? So let me try to show you here these two functions. So I have copied here the function for this g and f. So you can see here what is your here g and this is your here f. Now if you try to see, I try to choose here some value of here x, say 10, and y is equal to 20. Now if you try to see what I am going to do, I am simply going to execute here fxy. I am not computing here gxy just before you, right? So if you try to see here, as soon as I enter, it gives me here this value. So fxy, from here it has used the value of gxy. For that it has gone outside this function and then it has brought the numerical value of gxy and it has used it. Similarly, if you try to take here any other value of x like this, and if you try to repeat this command, you can see here this is here fxy, right? You have nowhere used the value of gxy, but that is automatically computed. That is the very strong feature of this R programming, which is quite popular actually, and that is why this R software gained the popularity. Okay, now we consider here one more example, and you have seen this type of functions in mathematics, and our objective is this: I want to make here a plot between here x on the x-axis and fx on the y-axis, right? So what this function is trying to say, it has divided the range of x into 3 parts when x is greater than 0. This function is given by this function. When x equal to 0, then the value of this function is given by 10. If this x is negative, then the value of the function is obtained by 2 plus x cube upon x. So I tried to take here some values of here x on the x-axis, and corresponding to which we need to compute the value of x first and then we have to plot. So we try to choose here the values of x between -1 to 5, and I try to increase it by say 0.2. So this will be -1.0 to -0.8 and so on up to here 5. So I will try to take these values on the x-axis, the values of fx on the y-axis, and then I will try to make here a plot. So now you can see here by looking at this function, you can see very easily that you can use here the if-else condition. So for that, first you try to do the basic operation, try to remove all the data and try to define the input variable. Now in order to use the if-else condition, you know that if this condition is true, then this is going to be executed, and if x equal to 0, then x is going to be, then fx is going to be here 10, and if both of them are not true, then whatever is left, that is going to be executed here like this. So now I try to use here the if-else if condition and if-else if conditional execution that you had learned earlier, and you can see here you can write this program very easily. So first I try to take here the first condition, that if x is greater than 0, then fx is going to be commuted by this exponential of x plus log 1 plus x cube upon x square, and I try to write down here if x is greater than 0, then within the curly brackets I write this expression. Now you know how to write down this expression in the R language. And then I try to give here second option, that if x is exactly equal to 0, then the value of fx is going to be 10. So this I write down here, that if x is exactly equal to 0, then the value of fx is going to be 10, and this is your under else if. And now finally, if you try to see your third option here, that if the first two conditions are not correct, then obviously the third condition is going to be correct, and then it comes under here else, and then 2 plus x cube upon x. And all these things I have enclosed in the program name or function name f. So I write down here f is equal to function within parenthesis, then put variable here x, and I try to write down all these 3 commands inside the curly bracket. But now here you have given the program to compute the fx. Now you need to write down the program that how you can create the curve between x and fx. So for that you try to define here x and then plot command. So I try to define here a new program here h, and then I start here the program. So first I have to generate the values of x. So I try to use here a command sequence from -1 to 5 by 0.2, and then I try to define here the value of fx as here y, and then I try to initialize it y equal to 0, and then I have to compute the value of fx, that is your here y, for each xi. So it will be like here that I want to compute the value of yi for each value of xi, right. So for that I try to write down here a loop. Well, you can do it directly also, but I am trying to write down here a loop, and then I try to write down here y square bracket I is equal to f of x square bracket I. That means for each of the ith value in the x, the value of y is going to be computed using the function f. You are nowhere given here f. What is here f? That we don't know, because this has been defined externally here. You can see here this is not a part of this program. So once again, as we did in the earlier example, it will go outside the program and it will try to compute the value, it will bring it inside the program and it will try to execute it. So then I try to use here the command here, simple plot command, plot xy, and then type I am going to take here L, that is line, right. So this is my program now. You can see here this program is very simple. This is your here f and this is your here h. That's all. And if you try to now execute it on the R console, this will be your here screenshot of the program. And now if you try to see here, we don't want it, but just for the sake of illustration, if you try to take x equal to 1, 2, 3, then the value of f is going to be like this. If you try to take here x equal to -1, 2, 2, 3, then the value of fx is going to be here like this. So these are the values of here yi's, right. Similarly, f of 0, you can see here f of 0 should be actually here 10, because your function at x equal to 0, it should be equal to 10. So and then if at x equal to 8, f value is here like this, at -4 the value here is like this, and so on, right. So now if I try to execute my here function h, so what it will do, it will try to choose, actually it will try to generate the value of x, and it will go outside the function h, and it will try to compute the value of fxi and then bring it inside the program, and it will use the plot command to create this plot, and the plot will look like this. You can see here it is not a very difficult job, and you can very easily it on the R console. Right. So let me try to execute this program on the R software, and then we try to see that. So I try to simply copy here both these functions, and you can see here these are your here functions h. So if I try to see here, this is your here f and this is your here h, right. And now we are going to create here a plot. Let me try to adjust my screen here. Now if you try to see here, I just want to, I'm not using here any of this here function f. I'm simply using here h, and as soon as you enter, you will see here you will get this type of curve, right. And then simply if you try to change the value of here x according to your choice, if you try to change the values of say here fx according to your choice, then you can create such a graphics without any problem, and you can plot such functions without any problem in the R software. So now in this lecture I have taken 3 examples, and my objective was essentially to show you that when we are trying to use the programming in the R software, then the input of a program can also be another function which is defined outside this program. And this is a very strong feature in the R software, and which made the R programming very popular. And now you have seen that within the R program also you can use the R programming language, and you can use the built-in packages also. And you have combined both the things together in order to find out the sum. Mean you don't need to write the program separately, but you can simply write down the function like sum, mean, etc. And all these functions, as a very obedient friend, they will try to give you the correct value. And now you can see here whatever you have done, means I have taken here very simple examples in the entire course to convince you that if R is a free software, it does not mean that it is going to give you the wrong value. And when you are convinced with this smaller value which you can compute manually with your own hand, then you should be confident about some bigger value, bigger data sets, and some complicated computation, that R is very dependable and R is always going to give you the correct value unless and until someone has made the mistake in the programming. So now with this lecture, I come to end to not only to this lecture, but to the course also. But I am going to finish this course from this lecture, but your journey towards the R software is going to begin from today after this lecture. I have tried my best to select or to give you some selected commands, syntax during this entire course. But as I said many times, this is not the end of the list of the commands and functions which are possible in the R software. There are many more functions, many possibilities are there, and in the last 2 decades R has made a very good progress. Now R has diversified to many areas in which people are trying to use it, but surely you will agree with me that covering all the topics in the same course is not possible. And as I said in the beginning itself, my job, my aim was not to teach you the R software, but my aim was to take out the fear of learning R from your heart. That's all. And I believe that now there is no more fear in your heart, and now you can start flying, and the sky is the limit for you to reach in your life, in your career, and in the use of your R software. So I wish you all the best, and I wish and pray to God that you achieve good lives, you get more successes, and I will see you sometime somewhere in some other course or sometime physically. Till then, may God bless you, and I will see you. Till then, goodbye.